Mercury cooks you, then turns around and freezes you solid. Venus doesn't even wait for the heat. The air itself is heavy enough to be the problem on its own. Mars finds a way to hurt you without a single extra degree of heat involved. Jupiter starts working against you before you've even reached its clouds. Saturn's wind alone could be the end of you. The ice giants are colder than anywhere Earth has ever recorded, and one of them might be the windiest place in the entire solar system. And one planet on this list won't try to kill you at all. We're going to figure out exactly why, and it's not the reason most people assume. One rule before we start. Ordinary human body, no extra gear beyond whatever I mention along the way, no rescue ship on standby, just you and whatever each planet decides to do about it. Let's start at the center of everything, with the one place on this list was never actually a candidate to begin with. The Sun. About 28 times Earth's surface gravity. No surface to land on either way. Just a sphere of plasma, roughly 5,500 degrees Celsius on the outside, something like 15 million degrees at the core. Get close enough to touch it, and touch is generous here, and your body doesn't burn. Burning takes time you don't have. You vaporize. Every molecule you're made of, gone in a 10,000th of a second, faster than a blink finishes. One thing worth remembering before we move on, because I'm only going to say it once, that same furnace wraps the whole solar system in an invisible magnetic bubble called the heliosphere. It's a big part of the reason deep space radiation doesn't shred everything sitting inside it. The sun that erases you on contact is also quietly doing some of the work that keeps the rest of this trip survivable at all. Step back from it and you'd think you were finally safe. You're not.
Mercury.
Everyone assumes the planet closest to the sun is simply hot, closest to the fire, most heat, case closed. Mercury doesn't work like that. It's really two different planets depending on what time you land. It barely has an atmosphere to speak of, just the thin haze scientists call an exosphere, too weak to scatter light or hold on to any heat. So even at high noon, the sky stays pitch black, and the sun itself looks 3 times bigger than it does from Earth, burning a blinding white. Daytime temperatures climb to 430 degrees Celsius. On that exact same rock, night drops to minus 180 degrees Celsius. Mercury basically looked at the right temperature and sprinted past it in both directions. Land during the day and your window is measured in seconds, a mix of thermal shock and unfiltered solar radiation working on you at once, with next to no atmosphere to slow either down. Land at night, you get much longer, close to an hour, but it's no mercy. Your body starts losing heat immediately, and hypothermia catches up well before that hour runs out. Better gear doesn't fully close this gap either. NASA's current suits are rated up to around 121 degrees Celsius. Mercury's day side sits at 430. That's a difference you don't engineer your way around. There is a narrow strip between day and night, the Terminator zone, where temperatures sit somewhere in between. Sounds like a loophole, and it kind of is, except that strip doesn't hold still. Mercury rotates so slowly that a full day-night cycle there takes around 176 Earth days. You'd be trying to keep pace with a boundary that moves on its own schedule, not yours. The same planet, just a very, very long shift apart.
Venus. Venus is the closest match to Earth in size of anything in this solar system. Similar diameter, gravity around 91% of what you're used to. That's about where the resemblance ends. You'd see the clouds before anything else. Soft yellow, almost pretty from a distance. That's sulfuric acid, and it's genuinely dangerous. But it's not actually the main event. The real problem is pressure. Around 90 times what you feel standing on Earth. For comparison, that's roughly what a submarine hull has to withstand 3,000 feet underwater. On Venus, that same crushing force is just sitting there at ground level, doing nothing but existing. Add temperatures around 465 to 470 degrees Celsius, hot enough to melt lead, and an atmosphere so thick that only about 10% of sunlight actually reaches the surface. So despite all that heat, you're standing in a permanent orange gloom. Between the heat, the acid, and the pressure, survival becomes essentially impossible almost immediately. Nobody's ever actually tested the exact order those systems would fail in on a real human body, and honestly, that's not a research grant anyone's rushing to apply for. That's not weather, that's the planet leaning on you. The air itself deserves a mention too. It's so dense down there that it exists in something called a supercritical state. Not quite gas, not quite liquid. If you could still move at that point, it wouldn't feel like walking through air. It'd feel like wading through syrup. One strange footnote: 50 kilometers up, floating in Venus's upper atmosphere, pressure and temperature are close to Earth-like. It's a big part of why NASA has floated, pun intended, the idea of cloud cities up there instead of anyone ever setting foot on the ground. After a planet that makes survival impossible before you've had time to react, the next stop is the one place on this entire trip that isn't trying to kill you at all: Earth. Every planet on this list has been trying to kill you within seconds or minutes. This one doesn't. Worth stopping and asking why before we keep moving. Start with the basics you've never had to think about because you've never had to. The air here sits at a pressure your lungs are actually built for, made mostly of nitrogen with just enough oxygen mixed in to keep every cell in your body running without a tank strapped to your back. The temperature range across the entire surface, coldest recorded to hottest recorded, still lands inside the narrow band where water stays liquid instead of freezing solid or boiling away. That's not a small coincidence. Liquid water is the one ingredient every version of life we've ever actually found needs. Then there's a part you genuinely can't see. Deep under your feet, a churning core of molten iron generates a magnetic field wrapping the entire planet, and that field deflects most of the charged particles the sun throws at us constantly. Without it, solar wind would slowly strip the atmosphere away, which is more or less what happened to Mars billions of years ago. A thin layer of ozone higher up handles most of the ultraviolet radiation the magnetic field lets through, filtering out the wavelengths that would otherwise cook every exposed cell on your skin. None of this is something you built. None of this is something you earned. You just happen to be born standing on the one rock in this entire solar system where the numbers landed in your favor on nearly every category at once. That should sound comforting. It's actually a little unsettling once you notice how many separate systems had to line up at the same time for that to be true. So here's a real question worth carrying with you into the rest of this list. Is that a coincidence, or is something out there actually working in your favor? Hold on to that. We're coming back to it at the end. Mars. Mars is the one planet on this list that will occasionally let you forget you're in danger at all. The sky carries a soft butterscotch tint. The sun looks smaller, farther away, almost gentle. Red dust stretches out under a silence so complete you'd swear you could hear it. If you didn't know better, you'd think you'd found somewhere livable. You'd be wrong, and not for the reason most people guess. It's not the cold. Even though average temperatures sit around minus 60 degrees Celsius and can drop as low as minus 133 degrees Celsius. Survivable with the right gear. It's not the radiation either, even though Mars gets a lot more of it than Earth does since its global magnetic field shut down billions of years ago and never came back. Both of those will eventually kill you. Neither one gets there first. What actually gets you is the air pressure, or the almost complete lack of it. Mars's atmosphere sits at less than 1% of Earth's surface pressure. That's so low, there isn't enough force left in the air to stop your own blood from boiling at your own normal body temperature. Not from heat, from the absence of pressure. Doctors call it ebulism, and it's exactly as unpleasant as it sounds. Your skin starts to swell and puff as gas that should stay dissolved in your blood forces its way out instead. You've got a window of a few minutes before hypoxia finishes what the decompression started. Your blood, in other words, decides it wants a career in special effects. This is also why an oxygen mask alone does nothing for you here, which trips people up more than it should. You don't just need something to breathe, you need a full pressure suit, or your body starts working against itself, no matter how much air you're carrying. Even if you somehow survive the landing, there's a second, slower clock running in the background. All that extra radiation quietly accumulating with nothing left to block it. Look back toward Earth from here and it's shrunken down to a single point of light. Not really a place anymore, more like a memory with a location attached. Here's the detail that gets me every time. About 4 billion years ago, this exact desert had oceans covering roughly a third of its surface, a thick atmosphere, real weather. You're not exploring an alien world so much as standing in the wreckage of one that used to look a lot like the one you just left. There's also a genuinely proposed, already lab-tested concept for building future Mars structures, something called astrocrete, made by mixing Martian soil with urea pulled from human urine. In tests, it comes out stronger than the concrete under your own feet right now. Mars is the last stop on this trip with solid ground under you. Everything from here, you just keep falling.
Jupiter.
Getting close to Jupiter is already dangerous long before you actually reach its clouds. Its magnetic field is about 18,000 times stronger than Earth's, wrapping the planet in a radiation belt lethal enough to matter well before arrival means anything. Say you had a suit that could somehow shrug that off, purely hypothetical, stay with me. You'd fall through white clouds of frozen ammonia at around minus 150 degrees Celsius into winds screaming past that close to 480 kilometers an hour. Keep falling and you'd pass deeper than any spacecraft has ever survived for long. NASA's Galileo probe made it roughly 150 kilometers down in 1995 before it lost contact with mission control. Everything beyond that line is farther than we've actually confirmed with real instruments. Both pressure and heat keep climbing the whole way. Eventually, you'd hit a layer where hydrogen behaves like a supercritical fluid. You're technically swimming through at that point. Go deeper still, and that same hydrogen gets squeezed hard enough to turn metallic, a dense liquid metal that doesn't just resist you, it traps you. At this point, Jupiter has pretty much stopped being a planet and started being a physics problem. If you kept going, impossibly, Jupiter's core sits at somewhere around 24,000 degrees Celsius, about 4.5 times hotter than the surface of the sun. Unprotected, you don't get anywhere near a countdown here. It's over before you'd have time to register it happened. If Jupiter kills you with brute force, the next stop does it with something closer to a blade.
Saturn. Saturn has the best PR of any planet in this solar system. Soft colors, elegant rings, the calmest photograph in every textbook. It is, without a shred of doubt, lying to you. Come in near the equator and you'd catch red and purple auroras lit by charged hydrogen. Genuinely beautiful for about as long as it takes the wind to reach you. Those winds hit around 1,800 kilometers an hour. Head for the North Pole instead and you'd find a storm large enough to fit 2 entire Earths inside it, sitting there permanently, like it's just part of the furniture. At those speeds, that wind alone would be enough to end you, well before you ever fell deep enough for the atmosphere's real pressure to become the bigger problem. Even the weather here has main character energy. Assuming there was anything left of you to keep descending, the pressure eventually climbs to levels found in Earth's deepest ocean trenches. The surrounding gas is turned to liquid, and at the very center sits a molten rocky core roughly 10 times Earth's size, running at around 11,700 degrees Celsius, more than double the surface temperature of the sun. One more detail, mostly because it's just a good fact. Even Saturn's rings, the decoration, move at around 70,000 kilometers an hour. On this planet, even the scenery is trying to kill you. Saturn is violent. The last 2 planets on this trip are something worse than violent. They're cold, quiet, and precise about exactly how they end you.
Uranus and Neptune. These two get treated like twins, and there's a reason. Similar size, similar makeup, both about as far from warmth as you can get, but they don't kill you the same way. One kills you like a freezer, the other kills you like something closer to a blender. Start with Uranus. It's the only planet in the solar system that spins on its side, with a full day lasting just 17 hours. And it holds the record for the coldest planetary atmosphere we've ever measured anywhere in this solar system, down around minus 224 degrees Celsius at the cloud tops. That cold gets you first. If you're somehow still intact and still falling after that, the pressure catches up, roughly 100 times what you'd feel on Earth, and finishes the job. Total time, start to end, under a minute. Freeze, then crush, in that order. Neptune plays a different game entirely. NASA calls it the windiest planet in the solar system for a reason. Winds exceeding 2,000 kilometers an hour, genuinely supersonic, the fastest ever recorded on any planet. Inside storms moving that fast, you're not looking at survival measured in minutes, you're looking at something closer to a second, maybe less. Neptune doesn't really have weather, it has a personal vendetta. One thing both of these frozen worlds have in common, and it's worth the trip on its own, hypothetically, deep inside each of them, pressure is intense enough to break methane apart and crush the leftover carbon into actual solid diamonds, which then fall through the atmosphere like rain. Diamond rain on both of them at once. Probably the most beautiful and most completely useless fact on this entire list, since you'll never live long enough to watch a single one land. You'd think that was rock bottom. There's one more stop most people forget belongs on this list at all. Pluto. Pluto isn't officially classified a planet anymore, technically speaking. That's a whole separate argument for a different video. What matters here is this. It might be the strangest death on the entire list, mostly because it's genuinely hard to say which system fails first. The ground is reddish, frozen, dim. The sun has shrunk down to a tiny, brilliant pinprick, barely different from any other star in the sky. The atmosphere is nitrogen, and it's almost nothing, thinner, relative to Earth, than even Mars's already thin air. Surface temperatures sit somewhere between -230 and -239 degrees Celsius. What makes it complicated is this. That same lack of pressure that caused problems back on Mars applies here, too, only worse. Pluto's air is thinner still, by an order of magnitude or more. So you're not just facing the cold, you're facing the same decompression risk that got you on Mars, running at the same time as temperatures that make Mars look mild by comparison. Exactly which one finishes the job and how fast isn't something anyone can time with real precision. Nobody's run that experiment, and nobody's volunteering. What we can't say with more confidence is this. Compared to Jupiter or Neptune, where you're gone before you've had a chance to process what's happening, Pluto isn't instant. However those two clocks race each other, there's more room in it to actually notice something is wrong. Your body loses warmth fast. Your thinking slows. And somewhere in there, whichever system fails first, it's over. Look back one final time and Earth isn't findable anymore. It's just one more point of light, lost among thousands of others exactly like it. Home didn't just get smaller on this trip. It became a rumor. One small, genuinely open question to end on, because not everything needs to be grim. NASA's New Horizons probe found hints that Pluto might have had recent liquid on its surface. Nobody's fully sure what that means yet. So here's where all of this actually lands. But it's worth being precise about which question we're answering, because there are two hiding in here. First, fastest to slowest, purely by how long an unprotected human would last. Jupiter and Neptune are effectively instant. Venus and Saturn give you seconds, not minutes. Mercury's daytime side is brutal and fast. Its night side buys you longer, closer to an hour, but it's still a losing hour. Uranus gives you under a minute. Mars gives you a genuine handful of minutes. And Pluto, strange as it sounds, might actually be the slowest, quietest one on the list, though exactly how slow is a question honest science still can't answer with full certainty. That's one ranking. There's a second, completely different question worth asking. If you had real technology, an actual mission, years of planning, which of these worlds could a human realistically try to live on? That's not about speed anymore. That's about resources, radiation you can shield against long-term, temperatures you can build around, and whether there's anything on the surface you could actually work with. By that measure, it's not close. Mars isn't Earth 2.0. It's just the least impossible option we've got. Thin air, brutal radiation, and brutal temperatures and all. Which brings us back to the question I asked you to hold on to back when we stopped at Earth. Is it an accident that one planet in this entire system happens to have the right pressure, the right temperature range, a working magnetic shield, and a stable amount of water all at the same time? Not entirely, as it turns out, though protected is a stronger word than the evidence really supports. In 1994, a comet called Shoemaker-Levy 9 slammed straight into Jupiter instead of continuing toward anywhere else. Scientists still argue about how much of a role Jupiter's gravity actually plays in shielding the inner solar system. It pulls some objects in, but it can also fling others onto new, more dangerous paths, so calling it a dedicated bodyguard oversells it a little. The moon's surface tells a quieter version of the same story. Every crater up there is proof this neighborhood has never been calm. The moon just happens to hold on to its scars, while Earth's weather and geology slowly erase our own. And that heliosphere we mentioned all the way back at the sun is still out there right now, genuinely cutting down how much deep space radiation reaches this part of the galaxy in the first place. None of that adds up to Earth being guaranteed. It adds up to Earth being lucky in ways that are only now becoming clear to us. Every world we just visited spent billions of years failing to become a place you could survive. One of them didn't. You're standing on it right now. So, do you agree with this ranking? Or is there one I got wrong? Tell me which planet you'd swap and I'll dig into it properly. See you in the next one.